Alright, here we go with the worked solutions to the Number and Fractions Test 2018. So let's get stuck in. Alright, the first section, question 1, involved using either an algorithm or otherwise to evaluate each of these. So evaluate basically means state this in its simplest form. So I personally would recommend that you use the algorithm for all of these and have a good idea of what the answer should roughly be by using approximation. So this is roughly 500 take away 50, which is 450. So my answer to this should be roughly 450. Let's run the algorithm. 492 take away 45. Now we're going to do 2 take 5, which we can't take 5 units from 2 units because there isn't enough units there. So let's grab some more by getting 10 or changing 110 to 10 units. 12 take 5 is 7, 8 take 4 is 4, 4 take nothing is nothing. The answer is 447. Question 2, this is roughly 240 plus 80, which is roughly 320. So my answer should be roughly 320. Alright, let's do the addition. 239 over 82, it doesn't matter if you put it the other way around, 82 plus 239, but I generally like to go larger number first, smaller number second out of force of habit. 9 plus 2 is 1, 3, now we're going to do 11, 2, 1, 3, 321, we guess 320, answer 321. Alright, this question here, again what we're going to use is a break apart strategy on this one, so I'm going to do 15 multiplied by 10 multiplied by 5. I can also do, and it's probably easy to do, 15 multiplied by 5 multiplied by 10. So 15 fives is, we can get an algorithm to generate that for us. 5 fives are 25, 2 1 fives are 5, and 7 75. Then we go 75 multiplied by 10, so 75 tens are 750. Alright, this one here involved seeing how many times 6 goes into 450, so we're going 6 into 450, and let's go 6 into 4, which doesn't, 6 into 45, which does, 6 8s are 48, 6 7s are 42, 3 left over, 6 goes into 35 times, so the answer is 75. Alright, so Jessie explains to Rosie that 2 squared is the same as 2 times 2, which is 4. So, what's wrong with that? Well, it's kind of true in a way, you know, what he said. Rosie then shows the following working when attempting to evaluate 5 to the power of 2. So she's said that that's 5 times 2. Okay, because that's what Jessie's explained. So the mistake that Rosie's made is she's assumed that the question is 5 times 2. Okay, so some sort of articulation of times 2 is the issue there. Alright, so correctly evaluate 5 squared. Well, 5 squared is 5 times 5, which is 25. So the very important thing to understand with this problem here is that 5 squared is not 5 times 2, 5 squared is 5 times 5. Okay, highest common factor of 12 and 32. So got a lot of students writing 2 down for this one, but the best way to do it is to quickly go through all of the factors. So 1 times 12, 2 times 6, 3 times 4. So they are the factors of 12. 1, 2, 3, 4, 6 and 12. Now let's do 32. 2 times 16, 3, 4 times 8, and that's it. So these are the factors of 32. We can see here that 4 is the one that comes out as the highest common factor, or the one that they have in common. So therefore 4 is the HCF. Alright, state the lowest common multiple of 2, 5 and 6. So probably the best way to do it is to write down 2, 5 and 6 and start going through the multiples. 5, 10, 15. Now we can see maybe with 5 and 6 that the lowest common multiple is actually going to be 30. 30 will also be a common multiple of 2, so we've probably got a winner there. So 20, 25, 30, 12 18, 24, 30, 30, and dot 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 up to 30. So 30 is the LCM. Alright, this one here was done pretty well by the girls in my class anyway. So what we had was 20 subtract 5 plus 15. And a lot of you guys use the acronym BIDMAS or BODMAS to do this problem. And really what I was looking for there is which one do you guys do first? And a lot of students think that, well, BIDMAS says addition has to come first because A comes before C, but the rule is it's addition or subtraction, whichever one comes first, left to right. Okay, so that's why we're really not fans of this thing here, because it is confusing. Instead we just apply the order of ops rules. So this is subtraction or addition. They're what we consider, I don't know, not even operations, but we do them basically in order from left to right. Okay, so what we're going to do first of all is the subtraction, which is 15 plus 15. So I'm changing 20 take 5 to 15, and 15 doubled is 30. Alright, this one over here is all sorts of mixed operations going on here, but I think the first thing we should do is evaluate the root 16. So we're going to go 2 times, instead of root 16 basically the answer to this question is what number when squared equals the number under the square root sign. So that's going to be 4. Okay, now our next operation is going to be somewhere within this brackets, and it's going to be the multiply, because multiply takes precedence over subtraction. 2 times 4 take 4 plus 2. Alright, over here we're going to do 4 take 4. Now we've got 2 times nothing is nothing plus 2, which is 2. Okay, so Daniel would like to find the prime decomposition of 48, and he's generated this factor tree. So we started with 2 and 24, so let's break down 24. We could go 6, 4, 2, 3, and 2, 2. There's heaps of different ways of doing that, so don't worry about what you did as long as you got 2, 2, 2, 2 and 3, it's fine. Show that the product, now the product is multiply of the prime factors you found in A equals 48. So what we needed to do was say something like this: 2 times 2 times 2 times 2 times 3 equals 48, and then to show some working out that you've got that 2 times 2 times 2 times 2 is 8 times 2 times 2 times 3 equals 48, is 16 times 2 times 3 is 48, is, whoa, what's that, 16 times 2, whoa, what's happened here? Why am I not getting that right? Oh dear, I made a mistake back there. So let's undo that. Alright, so I could identify that I made a mistake there because the product of my prime factors wasn't going to equal 48. So 2 2's are 4 times 2 times 2 times 3 equals 48. 4 times 2 is 8 times 2 times 3 equals 48. 8 2's are 16 times 3 equals 48. And 16 times 3 equals 48, so 48 equals 48. Alright, so Daniel also believes that he's found the prime factors of 40 and provides the following calcs. So we've got 40 equals this. Now he's actually right, because 2 times 4 is 8, 8 5's are 40. But what's he done incorrectly? Well, hello, 4 is not a prime factor, okay, or prime number. So 4 is not prime, therefore not a prime factor of 40. Okay, the shading on the shape below, what fraction of the whole shape has been shaded? So if the whole, this is the whole then, and what we've got here is a quarter of the shape shaded. What fraction of the whole is half of the shaded area? So half of the shaded area would be this, and we can continue that breakup there, like so. And what we can see is half of this will be just that part there, which is one part out of 1, 2, 3, 4, 5, 6, 7, 8, which is 1/8. Okay, you could have done that using the double the denominator rule, but I don't like that rule. I like to really see you guys understand this. So if you cut apart your shape there like so and got 1/8, that's good. So the shaded part is worth 5/6, and if 5/6 was a quarter, it means the whole will be 4 lots of 5/6. So we're going to multiply 5/6 by 4, which is 26. Now I was happy with that as an answer because we haven't really gone through simplifying fractions, but many of you did 10 on 3 rather, and many of you even converted that to a mixed fraction, which was 3 1/3. Okay, how many of the factors of 24 are prime numbers? So let's consider 24 and the factors of. So 1 times 24, 2 times 12, 3 times, what is it? 8, 4 times 6, and they're all the factors. So it's going to be 1, 2, 3, 4, 6, 8, 12, and 24. Now, a lot of you said the answer to this was 3 because you included 1. 1 is not a prime number. 1's neither prime nor composite. Okay, it doesn't fit the description of a prime number nor a composite number. Okay, so 2 is a prime number. In fact, it is the only even prime number. 3 is also prime. 4 is composite. 6 is composite. 8 is composite. 12 is composite, and 24 is composite number. So, in fact, 2 of them are prime numbers. 3 squared plus 4 times 2 is equivalent to. Let's evaluate this, and again, a lot of you guys showed working for this, and that's good. Okay, so we've got 9 plus 4 times 2, just evaluating 3 squared. Alright, now order of up says the multiplication has to happen first, so it's 9 plus 8, and 9 plus 8 is 17, so the answer to this one was 17. Alright, Ms. Mount constructed the following shape using pattern blocks. The shape is worth 1. She tries to make fractions of the whole by using only triangles, trapezium and hexagons, and she's able to make all of these fractions except for one of them. Okay, so when we consider this, what we need to start to do is really chop up our shape. And what we can see pretty quickly if you start hacking your shape up is we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so I can certainly make 1/12 because that is a just one triangle. A quarter is the same as 3/12, okay, which would be 3 triangles, so I can make that. A half would be 6/12, which I could make that using trapezium and 3 triangles. 7/12 would be a hexagon, which is 6/12 plus a triangle, so 7/12. So therefore 7/8 is the answer. I can't make 7/8, and you can see why is there is no easy way to turn any of these, the 12ths, halves, quarters into, or turn 8ths into 12ths. It just doesn't, you can't multiply by a particular number or a particular whole number to make that into 12ths. So there's our answer there. Alright, many students in my class did this one quite well. 2 numbers have a sum greater than 20, so sum means added together is more than 20, and a product less than 100. Okay, so 20 plus 10 is 30, so that checks out here, but 20 multiplied by 10 is 200. Can't be that one. Alright, this one here, 11 plus 9 is 20, and the sum needs to be greater than 20. So 20 is not greater than 20, 20 is 20. Alright, 11 and 12, 12 and 11 is 23, so the sum is more than 20, but 11 12s are, what is it, 132, so no. 4 and 20 is 24, 4 times 20 is 80, which is less than 100, so we've got a winner. That's our winner. Alright, 2 multiples of 15 are. Many students went for A on this one and chose 2 factors of 15. Multiples are the times tables of a number. So the first multiple of 15 is 15, the next one will be 30, and there it is there. Alright, in this shape here, one triangle is worth 1/3. Total value of the shape, many students, or a number of students, said 1, okay, because he's so used to the whole being 1. But it's not always the case, and in fact this then is, if this is a third, this is a third, this is a third, and this is a third. So we've actually got 4 thirds here, or 4 lots of 1/3, which is 4/3. There's our correct answer. Alright, question 7, I don't know, about half my class I think got this one right, and what a lot of students started to do here with this one is actually try to run the algorithm by finding a lowest common denominator, and it would have been a really clumsy one, okay, and so ideally with this one here you actually didn't need to work it out, and so I'll try to sort of show what I mean by that. Okay, so that's not the best diagram in the world for quarters. Let's try that again. That'll suffice. Okay, so 1/4 is that. Let's consider a roughly the same shape here, and if I split this into 21 parts and shade 5 of them, that's really close to 5 parts out of 20. And actually 5 parts out of 20 is the same fraction, divide by 5, as 1/4, or almost the same as a quarter. In fact, it's just a little bit bigger than it. So that might be the shading roughly for 5/21. In that case, if you add a quarter and pretty much or almost a quarter together, we know that at a base level, a quarter plus a quarter is a half. So this is the only one, because if you look at anything here, none of these are even close to being a half. So that's the only appropriate answer. It's closest to a half. Alright, so we've got 2 chocolate frogs shared between 6 people. Okay, so we're doing 2 divided by 6. What does each person get? Well, the representation of division is this fraction here, which is 2/6. If I ate 2/6 of a frog, it's also the same fraction as 1/3, because I divide both the numerator and the denominator by 2. So, answer is 1/3. On to analysis. Alright, so we've got Ms. Clark using this large elastic band to warm up before her PT sessions, and the elastic band is 72 centimeters long unstretched, and stretched it goes all the way to 217 centimeters. So we're looking for the difference between the two, so it's 217 and 72, and we're performing a subtraction. 7 take away 2 is 5, 1 take away 7, we're unable to do that, so I'm going to change the 100 and change it into 10 tens. 11 take away 7 is 4 and 1. So therefore 145 centimeters is the difference. Alright, the unstretched elastic band is divided into 3 equal parts. So it's the unstretched one, which was the 72 mil one, and we're going to divide it into 3 parts. So that is 2 with 1 remainder, 4, therefore 24 centimeter is the length of each part. Another elastic band is used for a particular exercise is half the original 72 centimeter band. How long is this elastic band? Well, if you know your halves, the answer is 36 centimeters, so that was fine. But halving is simply dividing by 2, so 2 into 7 goes 3 times with a remainder, and 2 into 12 goes 6 times, so the answer is 36 centimeters. Alright, so Ms. Clark is administering a fitness test on Mr. Miller, and she marks out a square and requires Mr. Miller to run 4 laps around it. So how many seconds will it take for Mr. Miller to complete the 4 laps if each lap is completed in exactly 20 seconds? That's 4 laps, 20 seconds each, and that is 80 seconds in total. A lot of you wrote 1 min, 6 and 20 seconds, which was fine. Be careful if you write this, 1.2 or 1 minute and 20 seconds like that. We're going to teach you something about decimal numbers, but the answer is not this one here, 1.2 minutes. Okay, and we'll talk a little bit more about why it's not 1.2 when we get to the unit on decimals. Alright, distance around the square is 90 meters. How far will I run? So 5 lots of 90 meters is 360 meters. Okay, unfortunately, he pulls his hamstring 135 meters into the fitness test. What fraction of the second lap? So obviously this happens on the second lap. So I've done my first lap, and that was 90 meters long. So in the second lap, I've completed 45 more meters. So 135 take away 90 is 5 take 0 is 5. 0, 1, 13, take away 9 is 45. So I've finished 45 metres of that second lap, and the second lap is the same distance as the first lap, which is 90. So I've finished 45 on 90, which is exactly the same as a half. So therefore, halfway through, that's when I sadly pulled that hamstring. Okay, Ms. Tran has made 60 identically sized chocolates for a gift. She needs to design a box to place the chocolates in rows, and we're looking for 4 ways Ms. Tran could arrange the chocolates. And basically this is actually a common factor question. Okay, so we're looking for the factors of 60, okay, or numbers that multiply together to equal 60. Alright, so we weren't looking for a drawing here. Okay, so when we're talking about 4 ways she can do it, the best way is to actually describe some. So 60 by 1 could be one arrangement. She could do 20 by 3. She could do 30 by 2, or she could do whatever other ones you could have thought of. I'm trying to think of another one. 5 by 12. So of these ones here, which one is the most practical? It's probably the 5 by 12 because, you know, whatever your rationale was here, it wasn't necessarily fine, whatever it was, but it had to sort of explain something about, you know, why that was practical, because similar to other chocolate boxes. But even if you picked 60 by 1 and you said you were looking for something different, which would be a selling point, that would have been fine as well. Okay, 20 identically sized chocolates were covered in red foil, and 40 of the identically sized chocolates were covered in green foil. What fraction of the chocolates are covered in red foil? What we were hoping for with this one here is you just didn't do 20 over 40, which is a half, but rather an understanding of the Singapore bar model perhaps, that these are the red foil ones, so that's 20 of them all, and these are the green foil ones. So green is 40, red is 20. That means all of them are 60. We've got 20 out of 60, which is the same as 2 out of 6, which is the same as a third. Alright, this one here was a very tricky problem. One pedestrian walkway in Hyde Park is exactly 3.5 sandstone pavers wide. The pavers are arranged as shown. So the information sign says this is the total number of pavers used. Okay, so what I notice about this, and so how many pavers were cut in half? So this one was cut in half, 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 but can't keep counting that way. So I note that in these 2 rows here, I've cut 1 brick in half to form this row. So what I note here is it's taken me 1, 2, 3, 4 for those half bricks, 5, 6, 7. 7 bricks were used to make 2 rows. So I want to find out how many 2 rows there are here. So what I'm going to do is take 1750 and divide, or see how many times 7 will go into it. And this will tell me how many lots of these 2 rows I'll be able to make. So 7 into 17 goes 2 times a remainder 3, 7 5s are 35, 0. So there's 250 lots of 2 rows that make the 1750 pavers. Now, we just said before that for every 2 rows, 1 brick gets cut in half. And so therefore, 250 bricks were cut in half. Okay, and the very last question is this performance of the 72-story treehouse. It was a true story. I did go and watch that, which was riveting. At the performance, 2/7 of the people attending were adults, the rest were children. 2/5 of the children were boys. There was 120 girls at the performance. Okay. Alright, so how many children were at the performance? So what I'm going to do is, again, use this bar model technique. Alright, and 2/7 were adults. So I'm going to cut this up into 7s, 2, 3, 4, 5, 6. and I'm going to say that these are the adults here, 2/7. The rest were children, so this is children, 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 and children. Now 2/5 of the 5 here were boys. So that's a boy, that's a boy. That means the rest of them are girls. Alright, so 120 girls attending the performance. So the girls number 120. And we've got 3 parts is 120. So if I go 3 into 120, 0, 4, 0, that means each part must be worth 40. Okay, so the children are all of these boys and girls. 1, 2, 3, 4, 5. 5 times 40. Answer 200 children. Okay, how many people were at the performance? We've got 7 parts in total, so 7 times 40 equals 280 people. Okay, so there are the solutions there. We also had this enrichment stage. If you want to have a look at the answers for that, please speak to your teacher and we'll flip you a copy of those. But do have a go about these. All of these as well, you can Google those to find a little bit more about Sophie Germain, including who is Sophie Germain. So there's a bit of a mystery. Pascal's triangle. I mean, hidden in Pascal's triangle is all sorts of stuff going on, including, amazingly, this number sequence here, the Fibonacci sequence. Okay, so you can read up a bit more about that, and again, if you want any more information, speak to your teacher and they will send you in the right direction.